There
Okay.
are no
Now.
Yeah.
Okay.
Yeah.
Okay, so first of all, even before I start recording, let me share my screen. Just tell me when you can see it.
Yeah, I can see it.
Okay, I just want to pick up, I will start recording in a minute. I want to pick up on the event that we looked at yesterday before we move on to other things, if that's okay. I will start the recording now, so you will have it. Record.
Recording in progress.
Perfect. So we were looking at event 403, which is a flow event. And we went to, I'll just remind you, in the process of deciding whether this needs to move on to for investigation with Tawako, we wanted to have a look at the behavior of all the sensors in the DMA. So we moved to full graph mode. And again, this is something that you need to discuss amongst yourselves, but I would very much appreciate if you would share the results with us. In a regular behavior, this may be something already done by Tawako. It is up to you to decide whether you want them to do that part of the investigation or is it still with you. In either way, I, of course, want you to know how to do it. This is why we are diving in so deep into everything. So I clicked the full graph mode and I have the graphs now, and then I would click the location filter because I want to see the behavior of all the flow sensors in that DMA, as this is a flow event. Sorry. And I can either turn them on, check the boxes one by one, or I can click all the flow sensors. So I just clicked all the flow sensors and I will let it upload the data. I will remind you, as soon as we do not have only the supply sensor in the graphs, then we cannot compare to predictions because predictions are for the supply and not for the specific graphs. I'm turning off I can turn off the sensors one by one if I want by clicking on them, or I can just press hide all. I want to hide all the sensors and have a look at them one by one, see their behavior. I do not care right now about the supply sensor, so let's have a look. So we have this sensor, which is operating in a regular pattern. And we had this one, we will go back to it. We have this sensor, this inflow that has a regular pattern. And we have this sensor, which has a pretty much regular pattern until we get to November 28. Actually, yesterday, what had happened there? It has two spikes, but otherwise it is behaving regularly. So we can discard that. Let's go back to that sensor that we'd seen. I just want to push it back to pull the legend so I will see the behavior before the event started, which would be the 20th of November. Let's have a look at the last week and then pull it back a bit. Yes. And I know what the sensor is. It's the only one that's turned on. So I just want to click off I want to hide the legend just so it will not be blocking the view. And by the looks of it, what we have here, as we discussed yesterday, is a sensor that just started operating. Perhaps it was broken. Just showing the entire history. It's taking it a while to load a lot of history. Yes, so it looks like we had a sensor. Let's take it prior to August so we can discard the spike. Yeah, this is quite obvious here. It looks like we had a sensor that just started operating. And because it just came back to life when the event started, I would be attributing this flow event to incorrect historic data. Because what happened is when we get the history of the sensors, if the entire history is just a flat line, then this is the normal behavior and the historic prediction for the sensors. And then when it started working or was fixed, it started sending data and it influenced the supply formula. Supply went up and we had a flow increase event. However, I'm just looking at if we just take it for the last few days. I don't know what is going on here as well. So the data coming from yesterday, let's turn the legend back on. I will remind you, we can see if we stand on the data points, we can see the time in the legend here. So let's have a look. So yesterday evening, it had some flat lines. And then we have a flat line. This is estimated still. So something is wrong with the sensor. I think this specific flow event, I'll take it from the specific flow event can be attributed to incorrect historic data. We will discuss it when we discuss closing the events. But there is something wrong with the sensor. There is a possibility that you would like to inform Tawako to check it. A130557886. Let's see. I just want to open another UI. You can open as many as you want, by the way. I can work on several screens in parallel, so I can see different attributes of the system. Let's let it go in. I just want to see if there is a fault event for this specific sensor. I want to keep this view alive so I can copy the number, the sensor identifier, and I will stay, in the events. Let me translate this to English so I can see what I'm doing. And let's see. You cannot copy from the legend, but I have it here. If I go to the graph, it's this one. I can copy I can copy why doesn't it work? A lot of information. I can copy the sensor code from the menu, and let's see. I will go to the location now. I want to see closed events as well, all types of events, and I will go to the location, and I will click this one here. Okay, this is the customer code for the sensor. So I don't, in the location for the events or the graphs, I can use the sensor customer code as well, not just the DMAs. I want to see if there are any events that are related to the sensor. Okay, so we have no events that are related to the sensor right now. And seeing as the behavior was very, very weird, and it was only for a week or so, it looks like it's going back offline. This is probably something I would like to monitor for a while and not close off this event right away, but closing it off when I'm just contemplating, because This is already 1.3 weeks old, which means in a few days, the system would start picking up on the pattern. But if this is the actual pattern, then we don't mind the system picking it up. Is it okay if I put in a comment?
Yeah, you can put in the comment so that I will explain with Tawako about this sensor.
Hmm. Hmm. Mhm. Let's refresh. I've just refreshed the system. Let it come back up. Okay, so we have this. And I will, because this is the same, we haven't changed the status. I don't want to change the status because I don't want to assign it to Tawako yet. It's with you. I would recommend one of you set a reminder for this event for possibly tomorrow or Friday after you discussed it with the Tawako to make sure, and then you can close it off. We will talk about closing later today. I would like to show you, we discussed sharing an event yesterday or assigning an event. So now, since all the users are activated, if you share an event, you click on the mailing list and you have all the users that are active in the system. Also, if we assign, we click assign, and we have all the users. All the users in this assign, you see all the users that were given either partner or user permissions, not the view only, because if you assign an event to a user that has view only access, then it's pointless. They cannot do anything with the event. So you can only, in the assign list, you see only the users that can perform actions in the system that have either user or partner access. Okay?
Okay.
So you can see it now. Okay, so this is about this event, and we had covered the flow events. I would like to move on. I would pick up the speed a bit with the other event types, because we want to discuss in length when we get to closing events. It will be a bit longer. And I would also like to keep half an hour in the end to discuss the way you will operate with Tawako moving forward. So I will pick up the speed a bit, and we will now talk about pressure sensors, or pressure events, sorry. So let's start with this. And as I will remind you, we will look at it here, and then we will try to look at one event and move on. I'm skipping this introduction in the beginning. It's just portraying where we are. And let's talk about pressure events. So pressure events are based on the behavior or the pattern of pressure sensors We have 7 types of pressure events: increase or decrease in pressure, above or below bounds, step increase, step decrease, and PRV failure. The data requirements, we only need a historic prediction. Network prediction is irrelevant for pressure sensors. And as with the flow events, the criteria to raise such an event is for the tests of norm and duration and size and duration. Now, I'm going to review with you in the next slides just some examples of different subtypes and talk about each subtype of the pressure events. This is, we see an example of a pressure increase event. It is a classic example of a pressure increase event where we can see the current pressure in blue, I will remind you, has increased in comparison to the historic prediction in green. Criteria, as we've mentioned, of norm and duration and size and duration and the actionable rules, this is also relevant for actionable rules, were met, and a pressure increase event is raised. So you have the pressure increase. And here you see the opposite side. This is an example for a pressure decrease event. Again, pressure has decreased in comparison to the historic prediction. All the statistics, all the test criteria, norm and duration, size and duration, and the actionable rules were met, and we get a pressure decrease event. What you see here is called a below bounds pressure event. In order for us to have out of bounds events, we need to have the bounds defined for each pressure sensors. This means the bounds for their normal behavior. In here, we get an alert where a pressure sensor drops below the normal bottom bound of the pressure it's supposed to be having, or goes above the upper bound. You can see the bound that's defined in the system. You can see it in the dashed red line in the bottom. We do not need, you can see the historic prediction, but for this event to be raised, you don't need the prediction. It is you have a set point, a range actually, between the two set points for the normal behavior of the sensor, what is the top bound, what is the bottom bound, and you get notified when you have such an event. It's not mandatory to have these bounds for each pressure sensor. If you do not have those bounds, then you will get fault events when the system deems the pressure to be, or the sensor to be faulty. We will discuss it when we will talk about fault events. If Tobacco has very clear bounds for normal pressure, it is recommended to add the parameter to the sensors. It's network structure update. You have in the network structure Excel that we shared, you have a low bound and a high bound columns. They need to be filled for each sensor, and we can deploy it to the system. Okay.
So can the user with the full access can set the bound on this web? Like we have to update the network structure file, or we can set it by ourselves?
You have to update the network structure files, and then I will deploy them in the system.
Okay.
Okay. Every time you want to have a configuration or a network structure update, as mentioned, this is back office process that you will share with me and I will do. Okay, we will talk about it again. We will mention it when we will talk about the recurring or the regular meetings for you to have with Tawako. Now, as I've mentioned, we will discuss it when we talk about fault events. There are predefined normal behavior for bounds for normal pressure that are acceptable all over the world. And when a sensor behaves out of those bounds, then you get a fault event, not an out of bounds event. And so this is optional though. You do not have to have the bounds for every pressure sensors. And also, if you have some sensors that Tawako can give you the bounds for their normal behavior and others that don't, that's also okay. Once you don't have to deploy the bounds for all the sensors, only for the ones that you know of that they have. Okay, so this is just an example. And let's move on. What we see here is a pressure step decrease event. Such an event, this kind of event can indicate either an existing or an emergent problem, even if the value remains within the acceptable bounds. It's not a clear-cut pressure decrease, it's a step decrease. Such an event requires the increase or the decrease in pressure to be significant over a period of time. The rate of the change over that period will be higher compared to a regular increase or decrease. This does not require prediction. That's the main issue that sets it apart from a pressure increase or decrease. There's no prediction needed. This is only related to the behavior of the pressure sensor, the way it has steps going down or up, and the total rate of the change is high over a period of time, higher than a regular pressure increase or decrease. And it would sometimes indicate a problem that is still not an issue, but it's starting. And we have the PRV fault. I do not remember, maybe Tuan or Nam, do you remember, do we have any pressure sensors defined as PRV outlets in the network structure? Oh, let me start. Do you know, does Tawako have any PRVs in the system? Pressure relieving valves?
I think they have pressure valve, which they define as the pressure point sensors, which means usually the pressure sensor will be in place with the flow sensor, but there are some pressure sensor that stay specifically at some place to monitoring the pressure, which don't have the flow sensor next to it.
Mm-hmm.
So they define them as the pressure point.
Okay, but this is not actually what I've asked. You know what a PLV is, I guess, okay? The pressure regulating valve, if you have high differences, then you need to regulate the pressure. If at the outlet of that PLV point, you have a pressure sensor, you can define it as a PLV outlet in the network structure. Again, there's a column that's called sensor role, and the only entry that you can have in it is PLV outlet. And if we have, PLV outlets defined in the network structure, then you can have this specific type of event. It's only for PLVs, for pressure PLV outlets. And this detects an emerging problem. It would detect a deterioration in the behavior of the PLV to try to catch it before it fails. from a lot of customers, what we hear is that when a PRV fails, it has considerable costs because having the pressure increased all of a sudden for the consumers can relate in bursts in their homes. And it's also, I understand, it's costly to fix a PRV. So we try to pinpoint an emerging problem in the PRV, identifying the deterioration in the behavior of that PRV. This is an event that has, it needs a lot of historic data. It needs a few months of historic data. We collect the statistics of the PRV behavior. And this showcases a gradual increase of the daily amplitude or a gradual change in the daily maximums or minimums. So it takes a long time. We need a lot of historic data, and the minimal period of time for such an event to be raised, so the minimal period of time of the deterioration in the behavior is 5 days. So the shortest event you can have is at least 5 days old. And the criteria to close such an event would be a period of at least 3 days in which the amplitude goes back to normal. Okay, this is just, it's important to remember. You can discuss it later and see whether it is relevant for Tawako. What I would like to say, that because this has so many special parameters in raising such an event, and in the presentation you can see all the parameters that are required in the slide. I'm not going to go over them. We spoke about them briefly. You will have it. And I would like in this case to mention grouped events. We have two types of grouping of events. The first one, which is very relevant, is flow and pressure together. When we can see, for example, a flow increase and a pressure decrease at the same time due to either a burst or some sort of issue, we would normally, if we have a flow and pressure together and there's actually a leak, we would expect to see the both together. If they occur in the same time in the same area, they will be grouped. Or the second type of grouped events we have is an aggregation of the events of the same type in the same area. For example, we can have a group of no data events or a group of pressure decrease events in the same DMA. We just want to not overflow the customers with events of the same type. So we group them together. You will see the parent, the grouped event, but you can also, of course, see all the underlying events. And the idea is that the same phenomenon, whatever is happening in the DMA or in that area, impacts multiple meters in the same time, and we group them together. Let's have a look. This is what you are looking for. You can see an example here for a grouped event. When you see the flag on the icon, this is a flag for a grouped event. The little number would represent the number of events that are grouped together. So we can see here an example for a grouped event where we have a flow increase and a pressure decrease at the same time in the same area. As I've mentioned, the grouped event is flagged on the main event screen with the number, and you can go to the relevant icon on the events menu and view all the events that had been grouped together. This is the icon in the event menu. If you click it, you will see, like in the related events, but here you will see the grouped events and not the related events. Okay, you can access, and I will show you, we will just choose a random grouped event because you do have some. You can go to the history tab if you choose to ungroup them. It's also an option. And now to the main idea of what we're doing here. We looked at the different types that we have with pressure events, but what do we do? How do we go about managing them? So of course, first of all, after we've prioritized what event we want to manage, the first thing we want to see, we will look at the graphs and we will check the subtype. And I will remind you again, we want to decide, the whole idea is for us to decide whether the event is relevant. If it is not relevant, we will close it off. If it is relevant, we will update the process and assign it to Tawako. So the first step is to review the graphs and check the event subtype. In this example here, we see a pressure decrease event. We want to look at the prediction type, and we want to look again at the size of the anomaly. So this is based on historic prediction, as you can see here, and the anomaly size is 16 meters. Okay, you can see, as we've mentioned, you can see it either in the legend with the current data, and also you have the point where the magnitude was measured. In the icon, you see the magnitude, and on the graph where the hashtag is, you see where it was measured. Okay. Next, we can move the graph, pull it backwards to see the behavior before the event started, just to verify our concerns, like we did with the flow events. So we would want to move it backwards. And in the network graph, we have, in the bottom, we have different types of graphs. We will go to the pressure all graphs. Of course, we can also do this through full graph mode. And we would like to review the behavior of all the pressure sensors in that DMA. Okay, we can see here that all the pressure sensors in the DMA exhibit some sort of drop in the pressure. I will just remind you at this point that all the customer codes, all the meter codes are exhibited in the legend. So we can see it here. So we want to see the behavior. We will go to the history tab to check the event subtype. It is also portrayed in the icon. I'll just jump back up and show you. It is also portrayed in the icon. You have a pressure and you have this little arrow going down. That would mean a pressure decrease. But we would like to verify, just to make sure what the subtype is. We will go to the history. I will remind you, in the history tab, we have all the data about the event, all the relevant data. And we will see what the type is, pressure decrease. And we would like to check if there are any other relevant data or possibly any other relevant events in the DMA. This is the first thing. So if you decide the event is not relevant, you can close it off. And again, we will discuss closing events at the end of this session. And if you decide the event is relevant and is worth further investigation, you update if you decide it is relevant, the first step to do before you pass it on to Tawako is we need to check if there is a relevant flow event. As we've mentioned before, when we have an actual leak, we would sometimes expect to see a flow event and a pressure event at the same time, possibly grouped, not always if there is a difference in times. So the first step before we assign it, we will look for a flow event. So we would go to related events, and we would look for a flow event that happened in the same time in the same area. Okay, we have here, and if we look at the dates here, it's the 15th, there is no such event. In this case, no such event is related, no flow event. Okay. If we do find a related flow event, we will handle the flow events. We will handle only the flow events. We will manage it like we explained in the previous training. And we will close off or handle, we will close the pressure event as redundant. Again, we will explain it when we talk about closing events, but this is only if there is a relevant flow event, okay? If there is no relevant flow event, but, or related, sorry, flow event, but we do decide the event is relevant, in this case, we will change the status to in process and assign it to Tawako. Comment, of course, all the time. I want to show you just an example for a pressure decrease with a related flow event, a leak. So what we can see here, we're standing on the pressure decrease event, and in the history we can see a comment saying it had been grouped into event so-and-so. It was basically, it was grouped with the leak event. We will continue. In this case, we will go to the flow event, to the leak event, and we will continue managing the leak only, and the pressure event can be closed off, because this, in this case, the pressure event is only supportive information for the flow event. Okay, the system had found a flow event type leak and a pressure event the same time, the same DMA, it grouped them together, and we will continue managing only the flow. There's no point in managing parallel identical events. Sorry. So we will close off, in this case, we will close off the pressure event, and we will only continue with managing the leak event. You can see the times are parallel. So as I mentioned, we determined the event is relevant, but there's no related flow event. In this case, we will update the event status, sending it basically to Tawako by updating the status. We will add a comment, and we will assign it to the relevant user in Tawako for further investigation or action. I'll just remind you, to update the status, you just press Start Processing button. To assign the event, you press the Assign button and choose the appropriate user. And to add a comment, you can add the comment either in the History tab at the bottom or in the speech balloon in the icons bar. Now, when this gets to Tawako, for them to further investigate it, they need to look at the History tab, your comments, of course, the external events if they're available, as we've discussed, and the events location. And add a comment, keep updating the event. So they would want to look at all the comments that you've made in the updates, check for any updated or any relevant data in the History tab. They can, of course, or they should, of course, add a comment with what they are going to do, checking what is wrong with the pressure. Just adding the comment. We had discussed external events, which is optional. if they have their work order system and you wish to commence with an integration of their work orders into Takadu to be presented in the external events tab. It's not mandatory. It's very useful. It's a great tool for investigating. They can see if they already have a work order assigned to that area or to that sensor. If not, and they think they need to have operations looking or checking what's going on there, they can assign a work order from their system, and then we will see it here. And they would want to, if they have that integration, they would want to look at that to review if there are any work orders in the area that can give an explanation for that event. It is possible that they have work orders close by, not specifically in that location, but close enough to affect the pressure. Something is, they're either doing any sort of work there, for example, that may influence the pressure, and that may explain the pressure event. So it's a very useful tool. This is another option that we hadn't discussed so far. They can, or you can as well, sorry, tag events. You can tag events for future analysis. It's this option, this icon is available at any stage of the event management cycle. And it is configurable according to whatever the customer needs, be the customer you or Tobacco. You will discuss it. If you want to tag events, if you want them to tag events, it's up to you. You can later on pull all the data according to the tags and conduct some sort of analysis on all the events that you've had. We have two sets of predefined tag groups, which is system and general. And you can have any tag group that you want. Tag groups can only be opened by me, by Takadu. You give me the names, I open a tag group. And moving forward to open new tags, that is something that can be done by you, or is done by you, not by me. I only give you the tag groups to open under. So that's tagging. We will see, I will show it to you in the system. If they are still not sure whether the event is mature, or of course in the previous step, if you're still not sure, of course, you can share the event with the different users in the system, or you can set a reminder to review it later, as mentioned with the icons. I keep repeating those things because they will set eventually. I don't expect you to remember them after just one time of me showing, so I keep repeating them. So they've established that the event is relevant, and they want to know, or they have established whether the area is under activity or not, be it through the external events or checking their own work order system. And what do they do next? So if the area has no scheduled work, they can schedule an investigation or open a work order in their system. And then update the status to job pending, and of course comment. If they already find a work order in place in that area, again they would update the status, of course, to job pending and add the relevant comment. And basically afterwards we would just sit and wait for the event to be back to normal. I'll just remind you, in order to update the status, they just press the Mark Job Pending button and add the appropriate comment. And now they wait for the feedback, or they check it. They can set themselves a reminder, of course. And once the problem has been found and repaired, we want to return to the event to see that everything is back to normal. This is both, I would expect, Tawako to do that before they assign the event back to you for closing. And of course, I would expect you to do that once you receive the event from Tawako, just to make sure that the event is really over. So we want to verify that the gap in pressure decrease or increase, for example, we want to verify that the gap from the prediction is closed and pressure is back to normal. We can see it here. For events that are not based on prediction, what we're looking for is to see that behavior is just back to normal. For example, in an out of bounds event, we want to see the behavior is back within the bounds. I will remind you here that in every cycle that we run, any process cycle, the system would check if the anomaly is actually over. If the anomaly is still there for the system, it will reopen the event if it had been closed. Okay, so we want to check that. We see that this is verified. We would also see, and we'll discuss it when we talk about closing events, that there is a red ended flag near the event. And of course, once we see everything is back to normal, it's assigned to you. The event can also be closed off. And that's it. We have just a summary, a quick summary. So we discussed the different types of the pressure events, and they are here. We talked about PLV failures, and we had gone through the motion of managing the events, and I had showed you the two types that we have of grouped events, which are important for moving forward. Now I would like to stop this. Let's see, it's almost 10. Okay. And let us jump into Tawako's system. It's a good practice as well to see how we filter events. So let's make sure everything's translated to English. It takes a while. I want to look at current events. I only want to see open events, of course. I don't care about in process now and work order. They're all open. And I would like to see pressure events. Let's just wait for a second. It will be translated. Yes. So, okay. Let's filter those. We have 4 pressure events. What we actually see here are 4, and you can see by the icon. So we have pressure, and this is a step increase. Okay, I would look at as we've discussed, I would suggest handling them in the order they occur. So we would start with the oldest one first, and then we will move forward. Let's have a look at this one. I did not look at pressure events for Tawako yet, so we're doing it for the first time. So the first thing we want to have a look at, the graphs. And I can already see the issue here. So we look at the graph, and this is a pressure increase, sorry. I will remind you, and this is why we are not seeing the historic prediction. This does not require any historic prediction. The problem here, I will stretch the graph backwards and you will see. There are a lot of gaps in the historic data that we got for the sensor. Many, many gaps. If we press it even further, you can see. By what I'm seeing right now, this is it looks like a perfectly normal behavior, but let's just open this small section. You can see the arrow pinpointing the step increase. And I have to admit that I don't see an actual increase in the pressure. I'm just looking at approximately at the median, just to see the line, the arrow. It starts from here. This is about 23. and this is about 24. So there is some increase, a very, very small step increase in the pressure. Looks like it's still continuing. This is already around 27 if we take the dotted line. It looks like there's a small increase in pressure. Now, I do not know, I'm not familiar with Tawako's actual system. So I would not know what to make of it. I don't know, and I need your expertise to tell me if this is something that they would want to look at. Again, I'll just remind you, this says that slowly but gradually, there's an increase in the pressure that this sensor is measuring. If this is something they want to look at, they want to know of, then this should be assigned to them. Let's just have a look at the history. So the duration, this is a good point to showcase actionables. As we've mentioned, the pressure step increase and step decrease are longer events. So you can see the duration, you can see the start time of the event is October 24th in the evening. That's when the system identified the beginning of the rise. I think it's because the data came back, but I don't know. But it became actionable on the 13th of November. So it had measured a step increase in the pressure over the time frame between the 24th of October and the 13th of November, and it is still going on. The event has not ended. So there is something, again, if you know how to, anything about Tawako's system and you deem this to be normal, then you can close off the event. And if you think this is worth reviewing, that they need to investigate it and check what's wrong in that area or with the sensor, then you can pass it on to them. We will have a look at the related events, as mentioned, to see if we have any related flow event in that area. The answer is no. Okay, we have this is all the related events that we have, only 3 events. We have that step increase. We have a no data event on November 7th and 11th. Not necessarily for the same sensor, it may be for a different sensor in the DMA. And I would suppose that, especially as a training exercise, this would be a good event to change, to update to in process, to assign it to the right people or users in Tawako, and to quite possibly review it with them together when you train them, so you can learn a bit more about their system if you want, and they can see in depth what's going on in the system. Of course, bear in mind that you have the gaps in the historic data. Now, another thing, as mentioned, this is in the following steps of the management cycle, but you have if we move from the event graphs to network graphs, we have the pressure all. And here we can see all the pressure sensors in that DMA. There are 2 of them. And by the looks of it, the no data event is related to the second pressure sensor. You see this, it still has, it's the black one, it still has a lot of gaps as well. So something is either wrong with the extraction of the data or it's wrong with the sensor itself. So from the pressure all sensor, I cannot learn any additional data. Again, I think this is a good event to pass on to Tawako and to study it together. I would imagine then that we have that this second pressure event, tell me, is it in the same? No, it's not in the same DMA. This one is in the same DMA. So this would be the second pressure event of 4, I think. And no, this is a different one. This is also a step increase and decrease, and this has some it has data gaps, and it has some very weird behavior. You can see there's pulling it back. There's a period of time here where pressure has dropped significantly, and then it goes up. I don't know if this would indicate they had some maintenance done in that area where they dropped the pressure, or there was an issue and now they've raised the pressure. Also something that, especially as a training exercise, I would probably share with Tawako and try to look at what's going on there. It's still ongoing. Again, a pressure step increase. We can see the steps going up with the arrow. Okay, let's have a look if there are related events here. Nothing, no related events. Probably the idea is to okay. I'm just looking at the pressure all. In this DMA, we have 3 pressure sensors, and you can see the problem is only in, we have 4. Let's hide all the pressure sensors. It's very varying pressure. By the glance, it looks like the problem is specifically with this sensor. So there may be something just wrong with the sensor in itself. I would review that with Tawako. Okay. I'm stopping the share for a second. I would just want to know if we have any questions right now about the pressure events, and if not, I would very much like to move on. I have to pick up the speed a bit with the other event types. I will try to do that. And if we find this necessary, we will set another appointment for next week just to review again whatever we've gone through. Are there any comments or questions about the pressure events?
For the pressure event, the subtype of above and below bow. So we need to define the bow from Tawako. The system has a default bow by using the history data to create the bow.
No, it's a set parameter. We have to define it. What we do have, and we will talk about it now when we talk about fault events, we have default bounds for normal behavior, but they would only indicate that there is a problem with the sensor, not with the pressure. Okay, there's a huge difference. So the system does not calculate normal behavior bounds from the history. It's a set parameter that we need the customer to give to us.
Okay, I understand.
Okay. So normally I would now talk about transmission event, but I'm just changing you, and you have the flow in the presentations. I'm jumping to fault events now because I want to talk about fault events first and transmission events later, if that's okay. So let's talk about fault events. Fault events will be based on emitters' behavior, always. They do not require any predictions. They are available for all meter types that you have in the system: flow, pressure, if you have level, if you have quality sensors eventually, so on. Any pressure, any sensor type, will have fault events available. We have 2 types of fault events. We have one that's constant readings fault events, and then we have the readings out of bounds. Reading out of bounds are only relevant for pressure sensors. Okay, we've mentioned it. Now we will talk about it in depth. We will review the types of events in the next few slides, and we will talk about the managing those events. An event will be generated just by we have a set of rules that are relevant for each event type in the algorithm. We will explain, we'll take you through that. And then the criteria to end, for such an event to end, is just a return to normal behavior. Okay, no additional criteria. What we see here is an example for a constant reading fault event. This type is relevant for all meter types, as I've mentioned. It will be raised due to a series of constant values that we are getting in the files. When the system identifies such a series of readings, it doesn't have to be zero. I have to mention that. It does not have to be a zero reading. It just has to be a series of constant readings. Such an event will be raised. Now, the length of such a series and the number of readings is configurable. We have some customers that have sensors that have very long periods of no flow changes, for example. So, and in order to save battery life, when there is no flow change, no values or no readings are registered. The loggers wake up only when there is a change in the flow. So we get long periods of time with constant values. The system just applies a constant value to whenever there is no reading. It is configurable. The default that we have is a series of 10, at least 10 constant readings within 7 hours. The delta between the readings to be considered constant, it can be up to 0.001. That's important. Again, this is also configurable. We can determine a longer delta. We can determine a longer time frame or number of readings needed for such an event. This is the default. This is what we found works for most customers, and we just configure it in unusual cases. Okay, so this is a constant readings fault event.
Siri,
Yeah.
are you sharing your screen?
Oh, I'm not?
Yeah.
Please tell me faster
But
next time. Tell me faster next time. So this is the relevant slide that I've explained with the constant readings, what you can see here. Let me just 1 second. It just hid all of my screens. Everything's in hiding for me right now, so just let me bring it up. I'm sorry. Yes. So this is what I've just explained about the constant readings. You can see it's very clear-cut. And this is why I mentioned that it doesn't have to be zero, because a lot of the times when we get a constant reading, it's zero. And it's very misleading. It does not have to be zero. Sometimes, as I mentioned, when the sensors only register a flow change, then the last reading that will be sent constantly would be the last reading of the flow change. It can be 4 liters per second, it can be whatever. It doesn't have to be zero. It just has to be a constant reading over a predefined or configurable time frame. The default, as I've mentioned, is 10 readings with 7 hours, and the delta between the readings is 0.001 right now. Anything below that will be considered constant. Okay, that's constant readings, fault event. There's only one icon for fault event, and we will see how we can tell the different types apart. This is the icon for a fault event, clock. Now, readings out of bounds. We mentioned it when we talked about pressure sensors. It's only for pressure sensors or quality sensors. Quality sensors are irrelevant right now for Takadu. If they are relevant in the future, add them. As I've mentioned, we have predefined default bounds for normal pressure behavior, something that's kind of acceptable all over the world. They are 3 meters to 200 meters. It's very, very large bounds. When our system identifies values that exceed those bounds in both ways, if it's lower or it's higher, it will raise a fault event. It's not saying, this event is not saying something is wrong with the pressure. It's saying something is wrong with the sensor. The sensor is faulty. It's sending faulty readings. Okay, it's a very important distinction. This is not a pressure event, it's a fault event. Those predefined bounds, we can change them according to what the customer says. Okay, most pressures around the world do not operate in heights that are under 3 meters, or pressures that are under 3 meters or well over 200. So this is just an example of a readings out of bounds fault event for a pressure sensor, a unique case. Okay, now a note about flow events. Before the system raises a flow event, it would look at all the formulas where the sensor, in this case we're talking about flow sensors, of course, as I mentioned, we're talking about fault events. So it would look at all the formulas where this specific sensor is a part of. And for each one of the formulas that you have, sensor, the system kind of asks, is the change in the meter's reading, the fault behavior, is it significant for the formula? This is, of course, something that's determined by the STD variance, by the statistics. And we have two possible outcomes here. If the sensor is significant to the formula, the system will only raise a fault event. It would say supply is not correct and it cannot be used versus the prediction. Now, we did not see this case in the flow event that we've just noted. Okay, if you remember, we saw a fault event where there was a huge difference in the behavior of one of the sensors. The reason we did not see this for that flow event, we did get the flow event, even though the meter is obviously significant there, is that if you remember, what we had there is the exact opposite of a constant readings fault event. We had a meter where the entire history was constant, and then it started working. So there is no actual fault event for that sensor, and therefore, the flow event was raised. But if we would have seen the opposite, if we had that regular reading and then we would start receiving a series of zeros, then before raising that flow event that we'd seen, the system would look at it. It would determine probably that that sensor is very significant for the formula. And instead of raising the flow event, it would have raised a fault event of constant readings for that sensor. Okay, so this is one outcome. Now, if the meter is not significant in the formula, and it may be the case, sometimes the sensor contributes a very, very small portion of the supply, then the system will raise both events, a fault event for the sensor and the flow event as well. Okay, I want to show you just an example of this to make it clearer. So we can see here an example for a flow increase that was detected. Okay, the system checked and detected a fault event in the meter that affects the same continent supply formula that this flow increase event is about. In this case, the system chooses the fault event. Okay, it would raise a fault event. Now, in Takadu's system, if we can already give an explanation about a flow event or a leak, if we can explain it as a faulty sensor, then the fault is preferred. The probability of having a major fault event and a flow increase event in the same time is not very high. So if a meter has a lot of contribution, a very significant part of the supply, and has a fault in it, it's stopped working properly, then the possibility is that the flow or the increase in the supply or the decrease in the supply are caused by that faulty sensor and not by an actual supply change. So we would prefer the fault event. We would raise only the fault event whenever it's significant, and you would not get the flow event. It is important. Do you think I explained it clearly enough? Do you have any specific questions about that?
So you mean usually when the system will detect the fault event of the meter first, and if it's significant, it will raise the flow event, right?
No, exactly the opposite. When the system detects, I'll take it even backwards. When the system detects an anomaly in the flow, before it raises a flow event, it goes and it looks for fault events with the sensors that combine the formula. If it finds a fault event for one of the sensors, it would go and check whether that sensor is very significant to the supply. If the sensor is a significant part of the supply, we would get only the fault event, saying that the faulty behavior of the sensor is probably the reason why there is a change, increase or decrease in the supply. We don't want to it's not an actual, it would judge the flow anomaly to be unreal. It just derives from faulty data or a faulty sensor. If it would see that the sensor, the flow sensor, is a minor part of the supply, then you would get both the fault event for the sensor and the flow event. Because it would say, it's not the faulty sensor that's affecting the supply. This is an actual change in supply. Okay? I don't know if we can see an example of that. We will have to look. This is not something that happens, very often. What we saw with event 403 is exactly the opposite. We saw, as I mentioned, we saw a flow sensor starting to work, and it's a very big part of the supply. It influenced the supply, and you got the flow increase event. But this is not faulty behavior, so there's no faulty event. There's no fault event for the sensor. Okay, let's see. You can see
so
the sensor
in the 403 case, there is no fault event was raised for that sensor, right?
No fault event was raised for that sensor because it was exactly the opposite. The entire history was constant readings. So when the system learned the history, this is considered normal behavior. And then, it's no longer constant, and there's no, we don't judge such a behavior as being faulty. It started giving readings. You only got a flow event, with no indication that it's because of the way the sensor is behaving. This is why when we investigate an event, we would like to go and look at the behavior of all the sensors as well, because sometimes a flow event can just be explained, as we saw, by the behavior of one sensor. Okay?
Okay.
So this is the constant reading. Okay, so when we start managing a fault event, the first step we want to do would be to check the event subtype. As I mentioned, there's only one icon. We cannot see the subtype on the icon. We would go to the History tab, and we would look in the comments here, or in the data here, what the subtype is. You see here in the bottom, event detected, explanation, constant readings. So you will have two different subtypes, as mentioned. It would be either constant readings, which applies to all types of sensors, flow, level, pressure, so on, or explanation, readings out of bounds. In Tawako's case, this only applies to pressure sensors. They don't have quality sensor. So we would first look what the subtype is. This is the second subtype, readings out of bounds for pressure sensors, as mentioned. Okay. Now, the next step would be to, in the case of constant values, we want to check that the values are correct. Now, do you have any other external systems that Tawako uses, the SCADA system, for example? Are you monitoring that as well? Or is it just by Tawako?
Just by Tawako, they're just using this SCADA.
Just by Tawako, okay. So in this case, I would probably update the workflow, and we need to update it, because this would be the point then that you would need to pass it on to assign it to Tawako, because what they need to do now is check their internal SCADA system to see if the readings are okay. Sometimes the issue with the fault event is only in the extraction of the data or the transmission. Something goes wrong with the script and sending it to Takadu, and that's affecting the values. So they have to check if the values are okay. If the values are the same, and they say this is the normal behavior for that sensor from now on, you can close off the event. They can assign it back to you for closure. If the values are wrong, we want them to continue by assigning their event internally to their asset management team to check what's wrong with the extraction or sending the data to Takadu, or sometimes what's wrong with the sensor. I mean, they can see that they are getting constant values as well in their SCADA system, and they are not supposed to get constant values. And at that point, they have to go check what's wrong with the sensor. Something is either wrong physically with the sensor, mostly it's with the logger, but they would have to adjust that. I would do the adjustments to the workflow. I had not noticed that. I think it is the wrong. It's just rising up from our conversation now, and I will send it to you, because I think in the sometimes then you will see mostly you will see you will check the subtype of the event for fault events, and in most cases, after checking the subtype and deciding whether it is relevant or not, you can send it directly or assign it directly to Tawako for further investigation. So as mentioned, in constant values, they will check if that is what they are getting in their SCADA systems. If this is what they're getting in the SCADA system and this is okay, they can assign it back to you for closing. If this is what they are getting in the SCADA system and it is not okay, they should again update the status to job pending and assign it to their asset management to check what's wrong with the sensor. And then follow up, see that the problem is fixed, of course, and assign it back to you for closing. In the case of readings out of bounds, again, I do not believe that you can judge whether that is, if you have no access to their system, you cannot check what's going on there, so you cannot investigate it further. So in the case of readings out of bounds, they want to check if there is anything, any open work order there that can explain those unusual readings. If there is an open work order, they can just assign it to their asset management and change the status to job pending. If there is no open work order, then it gets a bit more complicated. The first thing to do is to check whether the units match what we are getting. Sometimes script goes wrong, or it was configured such like that in the initial script. If you remember, we have in the network structure, we have input units or data units, and then we have display units. In Tawako's case, it's both cubic meters per hour, if I remember correctly. Sometimes what happens is they either start sending the data in different units, and then the conversion in our system goes wrong, and the readings are out of bounds. I think in Tawako's case, we will not see it because the only thing I can think of is that something would go wrong and they would start sending it in liters per second. And since we are looking for cubic meters per hour, the only thing that will happen is that the readings would become very, very, very small because of the conversion. So I don't see it happening, but this is the next step to do. If the units do have, if they do find a discrepancy in the units, then they need to update us through you, naturally. This is something you can talk about in your follow-up meetings, of course, and raise it. And we need to update, either they need to update on their side, if the mistake is on their side, or if they find a mistake to be on our side and what we are showcasing or expecting to receive, then I need to update the network structure. This is something very rare. It doesn't happen that often. I think in the 2 years that I'm working with Takadu, we found one customer had once found a sensor where the units were configured wrong. So it's very, very rare. It's normally not the case, but we do need to review it with constant with out of bounds reading. Okay, so you would check the subtype, you would assign it to Tawako, update the process, in process, add a comment. You can, in the comment, you can already tell them, what you think, what is the subtype and so on, what they need to check, what you think they need to check. And when they receive it, they will check in their internal systems, see if the values are okay, if there is a work order there, if the units are okay. They will update it to job pending. They will wait for the problem to be fixed, see that everything is back to normal, of course, and then it can be closed off. I just want to show you, again, this is the external events tab when it's available. As I mentioned, very helpful. I'm just running you through it because I do want to fix that. The data units, just one note about that. We can always see the data units that we are displaying in the legend. Okay, you will have it in brackets in the end. And with Tawako, it's cubic meters per hour. So, and this is only the display units from the network structure file. So they have to check in the background. This is why it's with them, that these are also the units that they are sending according to the network structure. I'm just running. As I mentioned, if it is a data issue, units issue, sorry, and it's on Takadu's side, you need to contact us for updating. The one I can think of, for example, is sending us, having the pressure sensors configured for receiving meters and showcasing meters, and maybe a new sensor will be configured to KPAs on Tawako's side, and we will get KPAs and showcase meters, and then all the sizes, all the measurements will be wrong. Okay, so you need to contact us. Of course, you can always share the event between the companies, and always comment and so on. Just a reminder of how to update event statuses, as you've seen, and how to assign. It's always there, just so you will remember how to do it, how to comment, where to add comments. And once the problem is fixed, it means the readings are back to normal. Of course, we want to check to the event, return to the event and check that everything is back to normal. We will go back to the event and we'll check for bound-related events, fault events. We will see the readings are back to normal bounds or default bounds for long enough. And for constants, we will see that the data returns to be non-constant just for long enough. And this also is according to what the system decides. You can see here a classic example of a constant readings fault event, and the data is back and the event is over. It was just a failure with the logger. Something had gone wrong with the logger there. Okay, we can see the event a sec, and then it will be expected to be assigned back to you by Tawako to close off the event, and we will talk about closing events. And I'm just making, if it's okay, I will make myself a note on the first, since we are working like this. I just want to add, let's just add a text box. Okay, sorry, I am sorry about this. Because the point in time in which a fault event should move to Tawako should be here and here. Due to the fact that you have no access, I thought you had access to the SCADA systems. So since you do not, I will update the workflow and then I will send it to you, of course. Now, I want to first talk about transmission events, and then we will see both event types in the system. Okay, and let me choose the transmission events. So, transmission events. Other words or other name that we normally refer to those events is no data events. Their official name is transmission events. They're based on a specific sensor, and they do not require any prediction, of course. The system looks at the transmission frequency for that sensor and adds 24 hours to that. And only after the transmission frequency plus 24 hours, we will get a no data event. So in other words, the transmission frequency for all sensor types for Tawako is 1 hour. So we will get a no data event after 25 hours where we have no data. For an event to be closed, we would expect it to, if you want to close an event quickly, we would have a backfill. We would expect a backfill for that time gap, not mandatory, of course. Yes. And of course, for the criteria to end is that readings are back to normal. As I've mentioned, the backfill is not mandatory. It's always recommended, not mandatory. And it has to be done manually, unless there's the next file will have the data gap in it. So wait, I was confusing. If you remember, we are getting the history in each data file. We are also getting the last, is it 48 hours or 72 hours of data for each sensor. There may be an issue with the sensor and it may not send data for 25, 26, sometimes 30 hours. But still within the following data files, we may still get the backfill for the data. Sometimes it's just a problem with the transmission. So you will see an OData event being open and very quickly afterwards closed by itself. We will talk about it when we talk about closing. Just to stress the point here, you will only see an OData event after at least 25 hours. We take the transmission frequency, we add 24 hours to it, and then a OData event is raised. And of course, it does not require any prediction. If you have several no data events in the same area at the same time, we would aggregate them into a grouped event, as we've mentioned when we discussed pressure events. If all the sensors from a specific input source do not send data, the alarms or the alerts will be raised on my side, not on your side. You will not get dozens of no data events. I will get an alert and I will send it to you. However, we can configure a user on your side, or even more than one, to receive those alerts as well. If you want to receive them, not just via me, please let me know who that user is and we will update it to the system. And this way, if we get an alert for an entire input source, SCADA, that no data is coming, you will get the alert as well. Okay, it's just as I will remind it to you when we finish. Now just let's have a look what it looks like. So this is an example for a no data event. It's very, very straightforward. You can see, the data just stops during this event. No data is coming in. And again, this is now that you've mentioned that you have no access to their internal systems, as I thought, this would need to be updated. They need to have a look at no data events. I want to ask another clarifying question. The extraction script, the script that extracts all the data and sends it to us, is this under your responsibility or Tawako?
SSI wrote that script and deploy on their server, and we have give them all the authority for that script.
Okay, so if something goes wrong with the script, they can check it. They know how to do it.
Yes. Maybe our software developer will work with them to get a quick result.
Okay. So again, I think we need to update this workflow due to the fact everything is in their hands. And basically, any new no data event can be assigned, you need to update to in process and assign directly to the personnel there. The first step there would be to check data, again, to check data availability on their side. So I suppose it would be assigned to their IT team. I'm not sure how they operate. Again, it would be very interesting to hear from you. So the first step, they would want to check their data availability. Maybe they, if the data is available, if the data is not available in the SCADA system, then they need to schedule a fix. Something is wrong with the sensor. They need to schedule a fix, update it to job pending, and so on. And when it's fixed, assign it back to you for closing. If the data is available in the SCADA system, let me see. Yes. So as mentioned, just writing a comment. And again, this just goes over how to write a comment, how to assign, and so on. And if the data, job pending, we've mentioned that. If the data is available in the SCADA system, the first step would be to check or to verify that the unique code they have for that sensor is the same as what appears in our network structure. Sometimes changes that companies do to the tags or to the codes they have in their SCADA systems, they forget to reflect that in updating the network structure. And they just change, the tag or whatever customer code they are sending. And if the customer code is different from what they have, what they're sending, and what we have in the network structure, naturally, we will get no data, and we get such a no data. Now, talk to me about this. They do not have they do not have the possibility to update the network structure. What they do have, and they can check, again, they're probably their IT guys, is, as I've mentioned, they can see the customer code that we are getting in the no data event in the legend and in the name. Okay? So they can compare the customer code that we have to what they have in their system, in the extraction. Of course, if this is not the same, then we need to update the network structure on our side to pick up on that sensor, and this is done via you. Okay, so if defined the customer code is not the same, then they need to write a comment, update you, and ask for a network update change, and basically you need to contact us. I would I would have them updated to status job pending. So it will stay with them until the data is back, and you can make sure it's back and then close it off. If the data is the same, if the code that we have, the customer code, is the same, then they need to check their transmission. Sometimes everything is the same, everything works okay, but something fails in the transmission. So their IT needs to check if sometimes they have an IT failure, or something failed on their side. And again, if something is wrong on their side, they need to update it to job pending, keep it with them until it's fixed, communicate it to you on your routine follow-ups, of course. And when the data is back, we will assign it to you to close off the event. Now, if the transmission is not okay, if the transmission is okay, then you need to contact us, and we will try to investigate it on our side. I mean, if they see that they have all the data and all the customer code is the same, and they are extracting the data and sending it to us, seeing that it lands in the FTP, then the only possibility left is some sort of problem on our side in the process, and you need to contact us, and we will check what's wrong on our side, if something is wrong. Okay, as was mentioned, writing a comment, contacting us, and so on. This is just how to contact. Tagging, we've mentioned tagging, I will mention it again at the end. And eventually, a no data event is over or is ended when data is back to normal. So when you see the data again, the readings are back to normal, and then this event can be closed off. And again, this exactly as the fault event requires an update to the workflow, because I thought the SCADA systems they use are accessible to you as well. I will update it. This is on Tawako's side and responsibility. Let's have a look at fault and no data events in Tawako's system. I want to clear all the pressure events. This would be a no data event and an error. Now, there will be quite a few no data events right now. Please do not let that scare you. This is something that we expect when a new system comes to life. We expect to see a relatively higher number of no data and fault events than we will afterwards. A lot of the times, customer thinks their sensors are operating, but when the system comes to life, they realize sensors are either failing, batteries dead, logger has some physical issues, and sensors are just not sending data. So this should be looked at and cleaned. At least in the beginning, I would give this a high priority for addressing all the issues with the sensors, and we can just sample. So as we've mentioned, I would like you to handle these in the order they occur. We can sort them by, let's sort them by start time. Let's translate this to, oh, just started. Let's sort it by start time, going up. Mm-hmm. The exact opposite way. Okay. So, for example, this sensor has no data since January 23, or this, yeah, December 22 actually. You can see even in the historic data, it had a lot of gaps, and this is dysfunctional. Okay. This needs to go to Tawako for them to check what is wrong with the sensor, as we've mentioned. If it's just a customer code that's wrong, if it's an issue with the units, or if the physical sensor, something is wrong with it, no battery, sensor is broken. It's sometimes, they turn off a sensor and they did not communicate that to you. They need to check that. It's just an example. No data events, as I mentioned, are very, very straightforward. I can suggest, I would like to suggest something. Well, this is also with faulty sensor for a very long time. Let me just show you. An option that you can do, I want to take the error. This is the fault events, right? What I'm showing here. Yes. What we can do, or I would suggest that you do that with Tawako right now. You can filter the list for no data events. Okay, to start off, you can export that list. You have the export button here. The export button gives you an export of all the events that you've filtered. So let's see how it looks. I have to apologize. I do not understand what I'm saying. Of course, it's in Vietnamese. Oh my God. And I can see this needs to be, this just needs to be converted into columns. And you have here the list of all the no data events that are open right now. And you can share it with them also as a list to check the sensors one by one. I think you have to tell me what I'm saying because I don't understand Vietnamese.
The first one is the ID event.
Mm-hmm.
Next one is the location.
Mm-hmm.
The next one is types and subtypes. The magnitude.
Okay.
Unit.
Okay, the dates I understand, yes. So you have the event and you have the location. It doesn't give you the ID, or the sensor ID. I'm going to the reports for a second, and I will show you something here. We will have continuous sessions talking about the reports module and the areas module. They are not in this training because the important thing is, of course, the event management. So let's see. Why do I not have any? Why do I not have any of this? I will check this. I want to show you how to extract the sensors that are not sending data. But this needs to be addressed relatively fast. Okay, so give a high priority for no data events now. Of course, flow events should be addressed as well, but they may influence. And this is a good example for a grouped event. On November 2nd, we had a grouped event of 27 child or children events. So I will stand on that, and I want to see on the events, you can see the related sensors on the map. So something had gone wrong on the 22nd of November. And this icon, you can see all the grouped events. Let's wait for it to open. Why does it not open? Okay. The reason it will not open that if you can see in the comment, on the 7th of November, events had been ungrouped. So you can see it separated from this group. And as you can see, on the one hand, this is only fish. So there was some malfunction with this sensor, but now it's back online. The event is ended. It's closed by the system. We don't care about it. Let's see. So please address the no data events. Let's have a look at this one. Is it not visible again? I'm sorry, it looks to me like we have a specific bug right now with this. I will check it. I will have R&D check why we are not seeing the children events. Let's see in the history. Okay. This is a very recent, it just started yesterday, a no data event for that sensor, for that pressure sensor. So, and I want to have a look at fault events as well. No fault events? How is this possible? Let me refresh for a second. Okay, so we have 31 fault events that are right now open, and let's have a look. Right now I'm just picking a random one. That's okay. This has been going on for 3.5 weeks. We want to have a look at what the subtype is. So I will go to the history tab and I will check. And in this case, you can see this is probably a pressure sensor, and it's readings out of bounds. So let's have a look at the graphs. Want to lose the supply. Okay, so we are getting readings for this pressure sensor, but the readings we are getting are 0. So while this is also a constant reading fault events, in the case of the pressure sensor, we are getting a readings out of bounds because this is outside of the regular bounds. Okay, so by the looks of it, this sensor is probably broken. And this needs to be handled again by, you need to have Tawako look at it. The behavior of the pressure of the sensor is faulty. They need to check their, as we've mentioned, they need to check their internal system to see the values they're getting in their SCADA systems. If there is, if this is the normal behavior for this specific pressure sensor, we need to update it. It's a specific case where the normal behavior is outside of default bounds. It doesn't happen that often. If the readings, if they have readings in their SCADA system, we need to check the customer code to compare it to what they have in their SCADA system, and again communicate through you to us if there's a need of a network structure update, and so on until, of course, if they see that the readings are the same in their SCADA system and this should not be the actual readings, it would suggest something is wrong with the sensor itself, sending, scheduling work, updating to job pending, adding a comment, waiting for it to be fixed, checking it's back to normal, and assigning it to you for closing. Okay. So the fault and the no data affect the way the system operates. Therefore, especially with a new customer or a new system that just gone live, we would recommend to emphasize, to give some priority to handling these events. Of course, alongside looking at the flow and pressure events, do not neglect them, but it is important to communicate to Tawako how many sensors are actually not operating, even if they did think their entire system is operational. This shows them they have right now. I did not, of course, I did not crisscross. It is possible to cross the events, but they have about what did we have, about 30 something events, no data events, and then they have 30 events that are fault events. And that means a total of around 60 sensors that are not operating properly as they should, according to the system. and this should be handled. Okay, let's have a look at this one. Is interesting. Let's just have a look. This is 3 days old. I want to have a look at it. And the fault started here. Let's see. Readings out of bounds again for pressure sensor. That's interesting. This is working, isn't it? This is the pressure sensor. This is the behavior. Okay. Now this is interesting. As you can see, it's a very, apart from that little fluctuation yesterday, it's a very steady pattern for that pressure sensor. And you can see readings dropping below 3 meters. This is below the default bounds. In this case, I would check with them if this is the normal behavior for that sensor. As I mentioned, sometimes we do have sensors that have different behavior than the default bounds. If they find, if in Vietnam, I'm not sure what it operates like in Toac or in Vietnam in general, if the default bounds are that we defined are wrong, we can define the entire system again for Toaco with different defaults. If a 2.5 meter pressure, for example, is still acceptable, it's still normal behavior, then we will just redefine the default bounds so they will not get, or you will not get as many readings out of bounds fault events. Okay, please, let's take note of that when we talk about, okay, 11. Now, I do want, we still need to have a look at very quickly about negative events and breach events. They're quite rare. I do not believe, let's see if we have any. I'm not sure we have any. I think if we do not have any breach or negative events, I would ask you to rely or lean on the presentations, the videos that we have in the Knowledge Center, and I will of course send you the full presentations. Can you tell me which one is the negative event? Because I'm not sure.
I think the -1 and the last one.
Oh,
Not
the
like
last one? Oh, okay.
Mm.
So we have two. Okay, so let's have a quick look at them. I'm going to take you very quickly through this presentation and ask you to rely on it. And of course, if we need to... Oh, sorry. What is this? Why is this recorded? And if we need to expand, we will. And of course, you have all the presenters' notes. So this is only relevant for supply formulas. They are based on the supply formulas of the DMAs. They will only be raised by a sequence of negative samples. So they can indicate several things. If it's an unclosed DMA, or possibly the formula is wrong, or that we have some sort of configuration issue. The relation directionality, when you have an inlet and it's defined as an outlet, the units, the customer code, if it's wrong, or of course, negative faulty data. Values are getting wrong. We don't need any prediction for negative events. And we need to address them and close them because negative supply is something that's actually unreal. I mean, if you think of physical negative supply, it would literally mean that water are being pumped out of the DMA instead of into it in the wrong direction. So our ability to monitor a DMA when the supply is negative and the duration where supply is negative is very, very limited. So we recommend fixing them as soon as possible. I mean, it's quite rare, but you need to address them as soon as they come. The first thing that we do, even before you pass them on to Tawako, is to see, we want to review the formula, okay? Again, we want to decide whether this is relevant. So the first thing we would do is to look at the formula, because they're based on a formula, and let's have a look. Okay, we will open the event and we will go to the network graphs. We will have a look at the flow all graph. And we will want to look at the legend, and we want to see that all the relevant sensors for that specific supply formula are in it. We want to make sure that we have all of them, and we want to make sure the relations are correct. Okay, so you can see, of course, the customer code, and you can see the relation in the brackets. And that's the first step that you want to do in order to determine what you have there. If you already find an issue there, contact us. Update the network structure or let us know there is some sort of mistake. You can contact me via email, and I will do the update and deploy it. If everything is correct, we also want to check that all the meters are available in the graphs. Okay, next step. So again, we will look at the flow all graphs. We want to check that all the meters that are available have are in the formula. We would check to see if any of the meters has any transmission issues or faulty behavior. Okay, you can see here in the zoom, you can see the dissected line, the dashed line. This indicates that there is a smart field used for the data of this sensor. It's the blue one in this case, indicating there is missing data for that sensor, which means it's the negative supply may be caused by missing data or faulty sensor. So you are looking for any sort of issues in the behavior of the sensor, any irregular behavior for the sensor. At this point, if you see that all the meters are available, but you do see some physical or transmission issues, so you see the behavior is faulty, update the status to in process, assign it to Tawako, comment about it, tell them what they're looking for, so that one sensor is behaving wrong and they need to check the behavior of that sensor, and then continue it from there, like do with any other faulty sensor. They need to check the behavior and so on, the data units and so on, and fix the problem if needed. If everything is available, and we've mentioned, check the data units that we see as opposed to the data units that we have in the network structure. If needed, assign it further to Tawako to check in their internal systems, as we do with a faulty sensor in a fault event. Okay. So they need to check the data units and the values. They can check, again, just mentioning the units are in the legend, and they need to check that everything is coherent between the system and what we have. just again show in case the units where they are. If the values are wrong, as we've mentioned with photons, they need to contact us via you for a network update to update the units on our side if this is the case. Of course, if they can sometimes find that the units they're using are wrong, and then they can just update it. Now, if everything okay, the next step is to check if the DMA is hydraulically closed. Are we missing any flow meters in the DMA? Do they have any valves open? If there are missing sensors or valves, will they be installed soon? Sometimes it's the negative supply is is caused because we already have a sensor in the formula, but the actual logger is not installed yet, or a valve is not closed. So you already have the data coming in, but it's faulty. It's affecting the supply formula and it's causing negative supply. So, and again, this is on Tawako's side, they need to check the DMA. Is it, as I mentioned, is it hydraulically closed? If they know they have any missing sensors or valves or any sort of those things, and they need to check whether they will be installed soon. If they are going to be installed in the reasonable time frame, let's say within a month, let's consider it a month, then what we would want to do is to suspend the event. In this case, I would ask them to send it back to you, have them assign it back to you. You may overrule me here. This is an issue of the workflow that I think you should decide between you and Tawako. My recommendation is they assign it back to you and you suspend the event. There is a suspend button for each event. Suspend button just basically makes the event disappear from the list for 30 days. It doesn't go anywhere, it doesn't close, it stays in the same status, but it's not in the list. So you don't have to look at it for 30 days. And then 30 days later, it just comes back to the list with a notification that you get that an event is no longer suspended. And then you can check whether the meter had been installed. If it had been installed and now supply is back to normal, you can close the event. If it hadn't been installed, contact Tawako. This is why I'm saying that possibly you want to decide the suspension is something Tawako would do, because they may, on the one hand, they may want, when the event is not suspended anymore, they may want to look at it, say, no, this is not fixed yet, and suspend it again. But then on the other hand, you need to be able to follow up on all the events and to see when sometimes, they just forget and they keep suspending an event and it's not being fixed, and you don't want that to happen. So I think this is something that relates discussion with them, the suspension. And I will show you. This is the button. Just click that and this is gone for 30 days. Again, it doesn't close. The issue is still pending. It just disappears from the event list for 30 days. So people will not continuously review this event because it's still an ongoing issue. Always recommended, of course, to accompany this with a comment saying event is suspended because sensor logger will be fixed during December. Not sure, I'm just giving an example. So always have them add a comment explaining why, or you add a comment explaining why, and then you can suspend the event. Now, if you see, or if they say that the period of time it will take for the fix is longer than that, then we have two options. We have an option to unmonitor a sensor or a DMA. And when we unmonitor a DMA, we unmonitor the supply. I think that in the partner, I will verify that, but I think in the partner permission, you can unmonitor the DMA or the sensors yourself. If not, it's done via me because this is admin. When we unmonitor a DMA, we basically unmonitor the supply sensor. It doesn't go away, it's still in the network structure, but it means we will not raise any supply-based events while that supply is unmonitored. We will still raise any sort of sensor-based events for the sensors that that are in that formula, that are part of that formula. So you will still have fault events, no data events, and so on. You can also unmonitor a specific sensor. That way you will not get any no data and fault events for that sensor. However, it does not take it out of the formula. If they know the issue is going to be a long time until it will be fixed, and I would probably talk about 3 months or more, I would recommend having a network update and disabling that sensor from the supply formula. Because maybe in that case, we will not have a perfect supply or the full supply, but we will have some sort of supply with a pattern that can be followed and monitored in that DMA. So I would strongly recommend, if you know a flow sensor that is part of a supply is misfunctional for a long period of time, 3 months and on, even 4 months and on, have a network, contact us for a network structure update and remove that sensor from the formula. And when we discuss removing it from the formula, I do not mean deleting that sensor from the network structure. We can set a date saying from this date on, like, I don't know, a sensor failed on November 1st. So I will have a network structure update saying, I will set, we call it operational until date. I will set the operational until date for that sensor for the 1st of November. And from that date onward, the supply formula will be calculated without that sensor's data in it. So supply is not accurate, perhaps. It's not perfect, but it does give us some sort of pattern that we can look at and monitor, even if it's not full. Because the other option is having a negative supply and not being able to detect flow events. So what we are seeing here, let's have a look at that negative event. First of all, as we can see, again, this is supply-based, so we see that the supply is negative. It's a very, very small negative, though. It's just, you see, it's it goes down to minus 1.4. That's it. I want to see, we can do it in the network graphs, flow all, or as mentioned, we can go to full graph mode and have a look at all the sensors. So the first thing to do would be to have a look at all the sensors. We have large consumers here. Okay, so this is the flow. In any place that we have large consumers in the formula, it means we have we can see it. This is a continuous net supply. We've discussed the hierarchy of the supplies. I want to see the large consumers as well. There's one. I clicked on the large consumer. And now I will see all the flow sensors that are part of the cont net supply. Let's go over them one by one. Right now, I'm just checking that they all have data. They all have data in the time frame, though by the looks of it, at least this one had some constant values. It's not below zero, it's not minus, this is positive. Let's have a look at all the ins first. This is the large consumer, it has data. This has data. It's a flat zero. This is an in. Okay. So here we can see in the, when I've tweaked all the flow sensors, you can see both the flow, the supply and the continuous supply with the large consumer. So what we can see is the supply is zero because all the ins were zero. And then the large consumer is naturally an out. And when we got the data for the large consumer, then we get the negative values in the supply. So I just want to have a look at the behavior only of that large consumer. Let's have a look at the way it behaves. I want to see the behavior over the history. I'm taking the coordinates file. It looks like it's a pretty regular pattern. And this makes me think, first of all, I would probably pass this on to Tawako for investigation. It makes me think, what comes to mind here is that something is faulty with the behavior of you can see it here. There are constant periods of time. Maybe something was wrong with the extraction. This is just a constant zero. Tuan, Unam, could one of you take note of that? Just a screenshot. I'll take a screenshot. I'll send you. You see this sensor, the ATOU something?
Yes.
Okay. So if you can see when I stretch it out, it has history, but it is a constant zero. So because the entire history is a zero, we will not get a constant values fault event. And I think this needs to be checked, whether this is the way it should be operating, because it's an in. I'm not used to seeing ins that send constant zeros. Okay, so I will send you the screenshot with the customer code of this. This needs to be reviewed. This is one of the things that happens in the first few steps of a new system. This is why it's important that you understand and know how to look at the sensors. We review their behavior to try and locate issues that are only from the fact that we just gone live. So what we detect here is a sensor where the entire history that we got for is constant, suggesting it hadn't been working for a very, very long time. Now, we will not get a fault event for this sensor because this is the history. So for the system, this is the correct behavior. Okay?
Okay.
This is it's only unique. I mean, in the upcoming period of times, as mentioned, when a sensor will start sending constant values, then you will get a constant values fault event. But because this is the entire history when we go live, then this is the reason you will not get one. I'll send you the screenshot. Let's have a look. And this is not working properly, and it may be causing the problem. This has values. These sensors have glitches in the, they both have some sort of, was there some sort of data issue yesterday? We keep seeing those spikes on the 28th. We did not get any alert for any data problems. You see, we're getting. Okay. For this event right now, the entire event, and I changed my mind. I would not pass it on to Tawako yet. This I would keep to monitor for a few days. I would handle with them the faulty sensor, see if this is actually faulty. If this is something that will not be fixed, I will take it out of the formula, as I've mentioned. But and if we add, I want to add the continuous one now. So we only had the negative supply in those two time frames where we got flat zeros for the ins. So as a negative event, I would just continue to monitor this. I would expect this to end within a day or so if we do not have any recurring issues like that, where the flow drops to zero, the inflow. Then within a day or two, this event will just close off on itself. It's not something, the negative event is not something that needs to be addressed. Okay? Can you understand why I'm saying this? Would any of you, I want to engage you. Does any of you, do you understand why I'm saying that this does not need to move to Tawako right now?
Yes, you want to monitor more a few days to check the fixed value of the sensor.
I don't think there's actually something wrong with the two inflows here. I think there was a problem with the data transferred to Takadu, but it's a very short period of time. We're talking a few hours. And if it does not reoccur, then the negative event will close off by itself. If this happens again, if the value drops again to zero, because we don't see that behavior in the past. If the value drops to zero again, and the negative event stays open for a few more days after that, I would communicate to Tawako and tell them to look at what has happened, what has gone wrong with the data they're transferring to us in those time frames. This is what is causing the supply to be negative, because the inflow is zero, but the large consumer, which is an out, has consumption. Okay? So
Yeah.
I would monitor that. I don't think this is an issue. And also, this is not something permanent. Supply is not continuously permanent, so it's not affecting our ability to monitor what's going on in the DMA. I mean, the negative occurrences are not that long. We were only blind for a short period of time, and then supply is back. So this is an event I would monitor for a few days before passing it on to Tawako for investigation, thinking it would probably close off by itself. But, as we've discussed, when I was investigating this event, I noticed the sensor that is not operating properly, and that I would take up with Tawako in the meetings that you will have with them. Now, can we continue today until half an hour more? Is it a possibility for you? Or do you have to go at exactly 5 o'clock?
Yes, we can.
Yes.
We can, okay. So can I have a 5-minute break? I just need to have a drink for my
Okay.
voice. And then
Okay,
we will
okay.
look at closing events, and we will discuss the ongoing meetings and your workflows, the protocols with Tawako, if that's okay.
Okay.
Okay, thank you. So
Okay.
5 minutes and I will be back.
Yeah, take a
Thanks,
rest.
guys. I'm pausing the recording.
Recording stopped.
Yeah, I'm back.
Oh, wonderful. Nam, you want me to just start? Or you want
Yes.
to wait?
Yes, please start. Hi,
Okay.
Tuan, are you there?
Yeah, I'm here.
Ah, the most important. Let me resume the recording.
Recording in progress.
So we want to talk now about the closing process. And just a reminder, it's going to be reminded here, actually, so no need. Come on. Oh. Again, this is already recorded, and we don't want the recording, we want to talk. Okay. This is the last training session. Okay, now, for the machine learning technology, the classification process is very essential. The system, our system knows how to generate the events based on the data changes in the current data and the predictions and so on. But it doesn't know exactly what really happens in the field. In the process of closing events, or the process of closing the events, it allows you as a customer, through you, of course, to document the essence of the event and actually give feedback to the system. Now, by choosing the correct closing reason, you can decide whether you want the system to learn the behavior of the supply patterns in that DMA. Someone is joining. You can decide whether you want the system to learn the behavior of the water in the DMA, or you wanted whether it should learn the new expected readings from a specific sensor, for example. And this also always improves the capability of the system to further detect high quality events for you. Now, the first distinction that we need to make in understanding the closing process is the distinction between events that are closed by the system and events that are closed by the user. So I want to first talk about events that are closed by the system. Okay. The main criteria for an event to be closed is that the system judges the anomaly to be gone and the behavior is back to normal. The system will only close events that the users did not start to manage. So any event that is already in status in process or job pending will never be closed by the system, only by the users. Okay, this is important to understand. We will, however, see the ended flag, this little red flag, when the system decides the anomaly is gone. At this point, the event end time will be set. For water loss type of events, leaks, flow increase example, and at this point where the ended flag appears and the event time is set, the system will also calculate the water loss. If we have the water cost, it will of course calculate the value, the savings. And then the event will have its status updated to closed by the system. And again, the crucial point here is if a user did not start managing the event. Okay, if the status is changed, we will see everything. We will see the ended flag, we will see the event end time, but we will not...
You're not sharing your screen.
Oh, again, I'm sorry. Okay, this is everything that we've just discussed. We will see the ended flag. We will see the event end time set and the water loss finalized. And we will see the closed by the system. And only in cases where a user did not touch or start processing the events. an event that is in status in process or status job pending, we will never get the closed by the system. Okay, let's have a look at it. So events that are closed by the user, just a second. Events that are already in the management process and they are not in open status, as I've mentioned, will not be closed by the system. Like with the other events, the events the system close, the main criteria here is that the system judges that the anomaly is gone and behavior is back to normal. Based on the management process of each event type, users are aware of all the remedial activities that the utility performed to solve the problems. And when an event is actually ended and can be closed, we will look for this ended flag. We will look that the event time is set and the duration and estimated water loss is finalized. And then we will update the status as a user to closed. While doing that, we will choose a closing reason. Okay, so we will now look at closing reasons. We have two groups of closing reasons. This is the point of time where the system needs to learn whether it needs to learn the behavior of the supply or the patterns during the event, or you want to tell it not to learn the behaviors during the event, and we will explain all the reasons and everything in the next few slides. Now, this entire process is actually after Tawako assigns the events back to you. Okay, it's making sure that the event is actually ended, that the behavior is actually back to normal, and then how do we close off? What do we do with the event? I would expect you to, of course, convey this to Tawako as well. I would expect them to assign the events back to you for closing only when they are actually ready to be closed. So as a first step in the closing process, we want to verify that the anomaly is over and that behavior is back to normal. We will do so by checking if the system marked the event as ended, that flag, and reviewing all the graph. Let's just look at some examples. So this is an example for what we look for in events based on predictions, such as flow and pressure. We want to verify the gap between the supply and the prediction has been closed and supply is back to normal. Okay, we can see here that the gap is closed, supply is back to normal. And of course, as I've mentioned several times before, the system checks it as well. This is an example. In this example, we can see the gap between supply and prediction has been closed. This is actually not supply, sorry, this is a pressure event. So we can see that the gap between the current data, not the supply, and the prediction is closed, and the pressure data is back to normal. We can see here the other parameters that I've mentioned as well. We can see the event marked as ended with the red flag. We can see in the duration that the end time for the event is set. Okay, just an example. Oh, sorry, someone is waiting to come in. Let me see that I'm just checking that I've admitted everyone that's waiting. Yes. Okay. This is an example of a trend event. Do you remember we spoke about trend events, flow trend events that are much, much longer flow events based on a constant increase in the night line? In this case, the criteria for an event to end is a consistent return to the night line of the nightline to the level it was before the event started for a duration of at least 30 days. It takes much longer for such an event to be raised, so it takes much longer for such an event to be ended as well. Just to mention, every data point on this graph represents 1 day. Okay, this is the nightline and not the supply. So every point is 1 day, and this is why it takes that much longer for that event type to first be raised and then be closed, and for the system to verify the event is really ended. This is an example of a fault event. This fault event was a constant values or a fault event, or no data. In cases of no data, of course, it will be the same. And we don't need any prediction. What we want to see is just that the data is back to normal. It doesn't have to be compared to anything. The system doesn't compare it. It's just back to, data is just back to normal, and the event, again, you can see that it is ended and the time is set. What we see here is specifically a no data event. We can see that the data is back. We can see the system mark this event as ended, and the end time is set. Okay. If you have an integration, or if Takadu has an integration, when they will have an integration of external events, the work order system perhaps, consult them or recommend to them to consider looking at their external events tab before they decide an event is finished or ended and assign it back to you. You can check for work orders or the work order status that are in the field and verify what is, verify what is happening in the field. I'm going back. Yeah. Verify what's happening in the field. Okay, you can see here that the work order status is completed. And we have all the other indicators as well. It's ended and time is set and so on. If we decide, when we decide an event is over, is finished by everything that we review, we can move on to the next step. However, if we still do not see a return to normal behavior, and we don't see all the systems indicators, even though we know the fix is already done, we still need to go on managing the event until it's over. So our next step, in this case, will be to add all the relevant data to the event, as well as to what we'll see in the next graph, add tags, locations, and comments. And I will just show you, just to bear in mind, I'm talking about the next step. We verified everything is over. If we see the anomaly still exists, we need to keep on managing the event. If, for example, Takadu will assign back to you a flow event saying they had fixed 3 leaks in the DMA, it is over, you can close it, and you go back and you look and you see that there is still a gap in the behavior and the system did not change or did not flag the event as ended, you may want to consider sending them back to look for more leaks in the DMA. Perhaps, there were 4 leaks, even if they closed 3. So that is that. If they assign back to you, for example, I'm thinking a constant readings fault event, saying they had updated or fixed the logger, but you still see a flat line with constant values, you may recommend that you comment to them to check also the extraction or check their internal systems again, saying data is still not back to normal and the event is actually not over and cannot be closed. So the first thing we need to look for is that the anomaly is gone and all the indicators that we just discussed. And then when we see all of them, we can move on to the next step, which is commenting, adding attachments, adding tags, and so on. You can have Tawako do any part of those things, your own layer of information on top of it, if you want. Let's have a look at what does that mean. So tagging, we've discussed. I have a document, a short document explaining what tagging is. I will send it to you for your consideration if you want to share it with Tawako as well. If you want to consider using tags, we have a lot of customers that are using tags, but then we have some that do not. It's up to your consideration. They are used for statistics and analysis. You can, or we can categorize the events by adding more information through tagging. You can use the same categories later to filter the events, and you can maintain, you don't need us, you can maintain the tag list according to your needs, according to Tawako's needs. I will just remind here, and it's mentioned in the document, tag groups, as you see here, system or asset failure, can only be opened by us as an admin, deployed in the system, and then later on, all the tags can be opened by you or by Tawako as users. And I will share the document with you. There is also in the Knowledge Center, there is also a video that talks about tagging events where you can learn more about this. This is just the icon. These are any sort of regular tags that customers use, just an assortment. The location tab, as we've mentioned, you can pin the location of the event on the map. It may be useful or as a starting point for future events in those DMAs. It may indicate where they had already found leaks in the past, and they can start looking for new leaks in that area. To do that, you go to the location tab. You can either pin it directly on the map, or you can use the address to set it on the map. Recommended to use. A lot of the customers use it. In the history tab, we would like to add now a comment with what had happened, some sort of short and clear explanation with all the information that will help you or Tawako's users in the future. Just what had happened in the event, if there was a leak, how was it found, where was it found, had it been fixed, and so on. Just a very short and clear explanation. So that is in the history tab. For example, here, they explained what had happened in this event before they closed it off, resolved as leak. And they added, you can see in the line above that the location was added. If you have any relevant files that you can attach them to the event, anything that will help you in the statistical analysis of closed events or investigations of open and new events, photos, for example, if you have any, you can attach photos, you can attach files, whatever you want in the clip, in the attachment clip. This is a known icon, so anything can be attached here. And then we get to the last step, which is choosing the correct closing reason and updating the event status to closed. Now, for that, we will use the close button. I will show you that in the live system. In the pop-up window that appears, we need to choose the closing reason. And why do we need to specify the right closing reason? So as I've said, the closing reason indicates to the system what had really happened in the field. And by choosing a closing reason, we're basically giving feedback to the system and continuously improving its ability to detect valuable events. When the event has ended, the system needs to understand whether it should not learn the event. In this case, the event time frame describes some unusual behavior, and any similar anomalies in the future needs to be detected. Or you want to indicate to the system that it should learn the patterns for future predictions. So the event is actually not an anomaly, but this is the normal behavior from now on. You don't need to memorize anything here in the explanations. You have everything shown and explained when you go into the closing reasons. So each closing reason, when you click on it, has a short description on the screen. If you hover with the mouse over that closing reason, you have a bit longer and more detailed explanation. And we will have a look at all the closing reasons right now. So leak is quite clear, and there was a leak that was detected in the field and closed. The definition between burst and leak is determined by you together with Tobacco, or normally it's just it would normally be a matter of the magnitude of the leak. A burst is just, a specific kind of leak, a very large leak. A temporary network change. The change in the flow pattern is due to some sort of change in the network. For example, there's some maintenance work and they are opening valves between zones and then closing them again. There is some construction going on that required some, that resulted in a spike of supply, but it's not a permanent thing. So anything that is a change in the network, not in the network structure, but in the network itself, but is temporary. It's not an actual leak. You don't want the system to learn the pattern, of course. Temporary network change. And now we get to the first closing reason, that is a learn closing reason. This is permanent network change. Okay, the change that were detected, you are telling the system that the change that it detected, or the anomaly it detected, will stay like this from now moving forward. We have 3 closing reasons that teach the system to learn the new patterns. They all have the word learn in the end, so you don't need, again, to memorize which one it is. And permanent network change can be due to, it says it's due to a significant change in the zone. For example, another development assigned to the same DMA, an increase, a large increase in the number of consumers within a DMA, and so on. So it's a permanent network change. It can also be attributed, for example, for the adding, judging the cover of flow sensors in a DMA to be not sufficient, adding another flow sensor, adding it to the formula may change, supply patterns may change because now we take up, we have more information, and this is a permanent network change. Explained. Consumption learn. So this is another learn reason. It would indicate to the system that from now on, this is the new pattern it should learn, what goes on during the event. It can be, it's something that is very, very common during seasonal changes, for example. You will get events with a either a supply flow increase or a usage event, and it's beginning of the dry season or the wet season, and the changes will be permanent for a period of several months. So you need to close off these events with consumption learn. This is the new normal. Faulty assets, it speaks for itself. The event was a result of some sort of out of order asset, a meter or a valve. This is a temporary. This is in the case of either a no data event, fault event. It can also be a flow event if the flow event is a result of some sort of sensor failing and it was not important enough for the system not to raise the flow event, but when the investigation was done, it was a result of the failing asset. So this is not a learn reason, of course. And the reason that we've already mentioned, which is incorrect historic data, as we've seen with that sensor in the flow event. So the prediction that we used for that event was inaccurate because it was based on some faulty data. The historic data was incorrect. You want the system to learn the patterns that are in the event. The anomaly is not actually an anomaly, it's the correct behavior. You want them to learn it, it's incorrect historic data. I think the difference between permanent network change and consumption learn and this learn reason is that consumption learn and permanent network change are saying actually that there is a new pattern. It is true from now on, while this reason actually indicates that the old pattern, it's not actually a new pattern. This is the way it should have been, but the data was incorrect before that. So, and the result is the same. The system will learn this behavior from now on for the predictions. Okay. We also have, of course, a communications issue. The event is due to some sort of problem in the telemetry. If there's a problem with the transmission and so on. Outstanding consumption. It can be, for example, if you have a holiday, like some sort of holiday resort, and there would be outstanding consumption in that area, some sort of local activity, and so on. So that one. And then we have redundant events. Redundant event, this event is unnecessary, or it is a duplicate of another event. In cases, as we've seen with the grouped flow and pressure event, if we found a leak and we want to close off the pressure event and just handle the leak, we would use this reason and we would close this event, and in the duplicate event ID, we would note, we have to put an event ID in here in order to use this reason. That we will write here the event ID of the event that we are managing. So in here, we will write the event ID for the flow event, and we will close off the pressure event. Okay, if this is a duplicate event, it can happen sometimes, then again, in this bar here, in this window here, we will write the ID of the event that we are continuing to manage, and we will close off the redundant event. Okay. And we have other reason. Now, this is only if none of the reasons that we already have in the system is describes what is going on. Now, I will specify, we don't have to choose a reason that is exactly what has happened. We have to choose the reason that explains in the best way what had happened in the event. And only if we don't have any reason that can explain what had happened there, we would choose other. We recommend using this as little as possible. If you find recurring events that you cannot choose the correct reason, please consult us. We'll talk about them. We'll see. Sometimes we can clarify and then you will know what is the correct reason to use. And sometimes it did happen in the past before that after discussions, we had added another closing reason. Okay? We try to keep them as a group, not to have too many of them. Another thing that we want to talk about are event labels. So you have 4 different labels for events. The first one we saw is ended. This indicates that the anomaly is gone, the system deems the event to be ended, and it can be closed. The second one is the frozen. The event frozen, if you have a flow event or any prediction-based event that goes on for more than 2 weeks, as I've mentioned, we want the system to start monitoring the area again. The event will get a frozen flag, and the system would start learning the new behavior, the patterns of the data in the DMA, and calculate the predictions according to the new readings. This is why we recommend strongly to close flow events within 2 weeks, okay? So the system will not starting picking up on new patterns that already have a leak in them. Reopen. So if a user closes an event, close an event while the system judges the anomaly to still be there, the system will reopen the event and it will be marked with this flag, reopen. Okay, so you can know when you are looking at the list that the system had reopened the event. And the last flag is revoked. The system will mark an event as revoked if it concludes it is not relevant, not that the anomaly is gone, the event is not relevant based on processing of new data. For example, we had a corrupted data sent to us in a certain data file, and an event was raised due to that corrupted data, and a day and a half later in the files, the data files, new data arrived, correct data. It had overwritten the corrupted data. The system looks at the new data, says, no, this event is not relevant, it should not have been. It doesn't eliminate it from the system, but it gets a revoked flag, and you don't need to be concerned with that event anymore. We recommend if you see a revoked flag on an event, stop managing it. You don't need to see it anymore. And this is just what the repair verification looks like, so you can see. Okay, so this is the closing process, just running through it. The idea is the anomaly is gone, and you need to now give feedback to the system about what happened. So you go through documenting, tagging, and commenting about the event, and then you move on to closing the event, choosing the correct closing reason. Let's have a look at it in the system, and just touching, reminding the different flags. Okay, I'm going to give 5 minutes to reviewing this in the system, and then we will talk about ongoing meetings with Tawako and the protocols. So let's just have a look. I want everything.
Yeah, may I have a question?
Yes, of course.
The question I asked yesterday. So in a case, I want to ask about your experience from Tawako and your customer that using is useful. In a case of leaking event occurs, after receiving a warning from Takadu Sams, so about a leak in a DMA. So what methods should customer use to determine the exact location of the list? and in order to send the repair team immediately there?
Okay. So first of all, they can use all their, I'll talk about this for a minute. The first, of course, they can use all their other tools that they have, such as if they have a customer call. I mean, they may, in the same time that they receive an alert in Takadu, there may be, if it's a burst or a very big leak, they may get a customer call saying there's water flowing out in the road here. So this is, of course, the obvious. We do not have in place a geolocation. What we can suggest, let's just grab, I want to grab a pressure event, if you don't mind. What we can suggest, which is the closest to that idea, is, let's open event, type pressure, or type. Okay. If you have more than 2 pressure events in the DMA, that's, I think that's the only situation in which this is really helpful. And you can give us the elevation for the pressure sensors. What we can do, you have in full graph mode, you have this feature called hydraulic head. Now, it is not operational here yet, but let's take all pressure sensors. This DMA has 4 pressure sensors. Now, if we have the elevation for each pressure sensor, we need the elevation, we deploy it to the system. And then when we click hydraulic head, what the system does is it takes the readings from the pressure sensor and it normalizes them on the same graph. Okay, it normalizes everything to be approximately the same. And then in the case of a flow or a leak event, we would be looking at, for the lowest point, the pressure sensor that has the lowest deep. And we would start, we would recommend to start looking for the leak between that sensor and the next one. So just, diving into the data, we have several customers that use that. They really like it. So just, this is not normalized, but just for a matter of speaking, if this would have been a leak event and the pressure sensors here would all have been normalized, I would physically recommend to start looking for the leak between the location of the black and the blue pressure sensors. But for this to be effective, we need the elevation for each pressure sensor. Okay, the height of how, what is the height? So we can normalize it.
Mm-hmm.
This is the one tool, the closest that we have right now to geolocation. Mm-hmm. Other than that, we can only recommend right now to use what we've shown with the location tab. This, of course, takes time to accumulate history, but once you already have the history in the location tab and all the pins, it is very, very useful. Okay, so setting the location when closing the event is very useful. And of course, if there is a possibility to create the integration with the work orders for Tawako, I don't know what sort of work order system they are using. We can discuss it in our future meetings. So if they have the work orders and they will have that data in here in the tab, then it would also help them. Sometimes it helps, when you investigate a flow increase to decide it's actually not a leak. It's not a flow increase because you see there is a work order, I don't know, half a kilometer away or somewhere in the vicinity in that DMA, and they've updated pressures, or they've closed valves that are supposed to be open, or open valves and so on, because they are doing something in the area, and those works can result in an increase in the supply, in an anomaly. So the work orders help, a very good tool for investigating not only what is going on, but where as well. Okay, this is what we have right now as an option here. We don't have, because the supply is calculated from the flow sensors. I cannot pinpoint the exact place of the leak to suggest to them. We have the combination of those tools that they can use, and it would indicate. Plus, normally the operations team know their systems very well. Normally they would know where to start looking. Now, in the cases of trend events, what normally comes from trend events, they result in a full-on survey of the entire DMA, because a trend event would indicate if it is an actual leak or leakages, it would indicate very, very small leaks, normally the kinds that you cannot see above ground. And in those cases, a lot of our customers just order a survey of the full DMA, and they would go surveying everything and looking for those small leaks. In the past, what I know is people, they would used to have a maintenance plan, and they would go through by DMA through DMA, surveying them, and not necessarily it would be in the right DMAs or the ones that actually needed surveying. So if you use the trend events and the other data that you have about the DMAs, it may help Tawaco to plan their surveys for the DMAs, for full DMAs, in a better way. What DMA is more prone to have leakages in it. For example, this is a trend. Let's have a look. This has been going on for 10 weeks. Looking back at the pattern, the difference is not huge, but it's there. And you see the night line is gradually growing. And I mean, when they investigate this is why the physical investigation part of the leak detection is done by Tawaco and not by you, because they know their system. And I'm talking about the physical system now. You need to have the knowledge of the system in order to be able to investigate or look for leaks. Okay? That is my question, my answer, the answer that I can give
Okay,
you right now.
Siri, our last question is, among Takadu SAM's outcomes to customers, which outcome ranks number one in customer review in your experience? And which outcome brings the most reputation to Takadu SAM among your customer?
What outcome is number one? You're talking customer experience or value?
Both.
Both. I think in general the visibility of the network in its entirety. I mean the visibility of the network is the one thing that our customers love the most in terms of customer experience.
Mm-hmm.
I know from some customers that some customers have a very large affection for the PRV fault events. Again, we have customers that have a very rural area, a lot of hills and mountains and so on. They have a lot of PRVs, and over there, having a PRV fail means taps and pipes exploding in customers' homes. So for them, catching a PRV before it fails brings the highest value. Of course, this is unmeasurable. You cannot measure it value-wise, because we work on on the savings, and this is not a system that makes money. It's a system that saves money and time and energy. So it cannot be it cannot be quantified, or we don't know how to quantify it. Sometimes they do not, because they do not know what the bursts would be. But when asked to say what they consider the largest wins that we have with them, at least 2 of our customers talk about the PRV faults. But of course, the leakages and the being able to prioritize DMAs for surveys with the trend events, and having everything visualized. I mean, in our next meetings, we will talk about tabs that we didn't touch. Right now, I want you to make yourself friendly with managing events. I want you to train Tawako about managing events, but there are a lot more things that you still need to learn about the system. We will, in our recurrent meetings, we will talk about the areas view and what we can learn from the areas view and what we need to do with it. We'll go over reports and show you what the reports are. And this is also something that I wanted to mention, in the next part of our conversation, but we're already there, so I will. Each month, we produce a report that showcases several KPIs that we choose to measure about the performance of the network, and we share it with you. Now, after we extract the first KPI, the first report, sorry, we will go over it with you, of course. I share it with you, not with Tawako. And you will take it from there. You will choose what you want to show to Tawako from that report, what you want to discuss, what you want to pass on to them, and so on. So this would be with you. We will do that. I will extract the first report next week, and I will have a look. I'm not sure that because, the system has just gone live this week, I'm not sure it will have any substance yet. So quite possibly the first report of the KPIs that we measure to share with you, and then according to what you want with Tawako, will be in the beginning of January. Okay, I just want to extract it next week after December starts and see whether there is anything that's worth sharing already. Because the system is so young, we will not have any events closed by the users yet. System sensor quality is still off because of so many no data events and so on. So I hope this answers a bit of your question.
Yeah, thank you. So I have another one question.
Yeah.
So saving from leaking loss is a remarkable outcome with customer, right?
Reducing water loss, yes.
Yeah. So
it saves a lot of money.
Yeah. So how is ranked so how to say in the customer KPI expectation, because in Vietnam it may be the top KPI of customer.
It will be the first KPI that you will see in the report.
Yes.
The first KPI we will measure will be the potential water loss that we saved. And it will showcase flow events that will be closed as bursts or leaks by the users, and the calculation of the water loss over a period of 30 days, 90 days, and 1 year. Sometimes, especially with trend events, the leakage is so small, it can go on for years before anyone notices it. And because we can pick it up and they can go looking for it and find it, we want to showcase how much money, or water in this case, they could have saved if this would have gone on for a year. So we will, if it's okay, we will discuss it when we have the first report. I will show you everything.
Yeah.
I will share the report with you. Even, you know what, even if it doesn't have any substance yet, I will share with you so you can see the format and you will be acquainted with what we are measuring. And again, if there is any way that you can pass on to us the water cost for Tawako, I can update it in the system.
Yeah, okay.
Then we can calculate the value of water as well.
Okay, sure.
Okay, I don't think we're not talking about the retail water cost, but the
Of course,
human.
in the purchase cost as a purchase cost.
Yeah.
I know.
Okay.
Okay, thank you. Thank you,
Okay.
Siri.
Now
Toàn,
I want to I have to have a few more minutes. I have to
Okay.
have a few more minutes. Okay.
Okay.
I want to
Okay.
discuss about very quickly about the workflows with you and Tawako. So this is something that we've seen yesterday, and it followed us. I have to update the no data and the transmission presentations before I pass them on to you. I will. Now, so you need to build, and these are suggestions, you need to build a daily follow-up protocol with Tawako. Of course, we expect you to visit the system daily and manage all the new events first. So you will go into the system, create a view, a customized view for yourself, take care of all new events first. Then you would like to have another customized view, revisit all the events that are in status in process, see if you need to ask Tawako something about them. You can confer with them on a daily basis if needed. Next thing, create a customized view according to what I've shown you, and look at all the events that are already in status job pending. Maybe something is already fixed and Tawako is just neglecting to look at it and assign it back to you for closing. You need to be on top of everything that's happening in Tawako's system. Okay, and of course, review the events that they assign back to you for closing. You can create a customized view for that by the assignment as well. This is something that needs to be done daily. It does not have, it will take a long time in the beginning because you're still not used to it. But as you do it on a regular basis, it will become shorter and shorter. Because as you can see, I can already go into an event and very quickly see if it is worth investigating further or not. You will gain that experience as well. It's just a matter of experience. And you need to have recurring meetings with Tawako, either weekly or bi-weekly, according to what works for the both of you. If you think you need it once a month, have it once a month. Build a protocol for those meetings. In each one of those meetings, and of course I will share this with you, you will review any open action items from the previous meetings, update bidirectionally about any progress made. You may want to choose some specific interesting events to have a discussion about them. In the future, we will discuss improving DMAs. So I would expect you to choose DMAs that have poor behavior and discuss with Tawako how they can be improved. I will convey to you, of course, updates about new features or new integrations available, and you can pass them on to Tawako as per your choosing. You may choose not to share them with you, it's up to you. And this is the point in time in which for you to discuss with them any needed network updates. You need to collect the data for network updates from them, if there are any. They replaced sensors, they are subdividing a DMA. Any changes in their network structure, discuss it with them, collect the data, any changes in configurations, and pass it on, collect it in the right format. If it's a network structure update, the Excel format. If it's other sort of integrations, talk to me and we'll see what format we need. And then you pass it on to me for deployment. We need to schedule a recurring meeting as well between us. I think maybe we would start with once a week like we did before. And then gradually, as you gain experience and you don't need me helping you or holding your hand so much, we can, drop it to once every 2 weeks or once a month. So my first question is, as we had with Tuesdays in the afternoon, I think it was noontime, can we have that recurring meeting every week? Is it possible, Nam, Tuan?
For me, possible.
It's possible. How about Tuesday afternoon?
Yes. That's what I'm talking about. So Tuesday afternoons.
Okay.
I will send all the presentations to you. Yes. Of course, I will update the fault